All right, welcome back to the deep dive. Today, we're cracking open a really dense technical document.
A spec sheet.
Exactly, a spec sheet for the NTI E-STHSB-N4085IND-100. It's an industrial temperature and humidity sensor.
Right.
And our goal here is to figure out what these numbers actually mean. What makes this specific 100-foot cable unit tick in really tough environments.
And right off the bat, you could see what kind of environments we're talking about.
I mean, the operating range is just incredible. It's built for everything from an Arctic minus 40 degrees all the way up to a blazing 185 degrees Fahrenheit.
Plus humidity from 0 to 100%.
And it specifies non-condensing.
And that's a key distinction. It means the air can be fully saturated, but you're not getting, actual water droplets forming on the sensor. These kinds of extreme ranges demand very specific performance considerations.
Which is why the accuracy numbers are so specific.
Exactly. Let's start with temperature. For most of its range, say 14 to 185 degrees Fahrenheit, it's very tight. We're talking plus or minus 0.7 degrees.
That's quite precise.
It is. But when you push it into that real deep freeze from minus 40 up to 14, the accuracy does drop slightly.
Okay.
It goes to plus or minus 1.6 degrees. But what's crucial for any industrial application is that they guarantee that performance. They tell you exactly what to expect, even at the absolute limits.
And I see the humidity specs follow a similar pattern. It's plus or minus 3% for, 0 to 80% relative humidity?
Right.
But then it widens a bit to plus or minus 4.5% once you get into that really high humidity zone from 80 to 100%.
And that's a classic physical limitation. As the sensor element gets closer to full saturation, it's just harder to maintain that same level of precision. It's a standard trade-off.
Got it. Now, it does all this on a tiny amount of power.
Oh yeah, very little. It's just a 5-volt DC supply.
5 volt, and it's sipping only 13 milliamps of current. That seems incredibly low. How does that not cause problems with data integrity over 100 feet of cable?
Well, that's where the communication protocol comes in. That's the key. RS-485. It's an industrial standard chosen specifically because its signal is highly resistant to noise and, all the electromagnetic interference you'd find in a factory or an industrial site.
Okay, so let's unpack that. This isn't like the standard Ethernet you have at home, which can get flaky and usually dies out after about 300 feet.
Not at all. The RS-485's digital signal is designed to be rock solid, which is why that 100-foot cable is no problem at all.
And it can go even further.
Precisely. While this unit is 100 feet, the spec sheet says custom lengths are available up to 1,000 feet, just on copper wire.
1,000 feet is already a huge distance for a sensor.
It is. But here's where it gets really interesting.
A fiber converter.
Yes, the optional EFSC fiber converter. If you pair the sensor with that, you can extend the signal up to 1.2 miles.
1.2 miles, that's 2 kilometers.
2 full kilometers.
Yeah.
To put that in perspective, that's more than 20 times the maximum length of a standard Ethernet cable.
So you're going from monitoring across a huge facility on copper to potentially monitoring something on the other side of a campus or a small town via fiber.
And all while maintaining that sub-degree accuracy we talked about.
So if we tie this all together, the big takeaway here isn't just that the sensor is tough.
No, not at all.
It's that it's engineered for verifiable accuracy over these massive physical distances. It's about data integrity where you absolutely cannot afford to be wrong.
Which, it raises a really interesting question. What kind of mission-critical infrastructure needs this? Where is accuracy so important even in sub-freezing weather that you need to reliably get a signal from over a mile away?
Remote data centers, maybe. Pipelines in remote areas.
Think about that. What kind of system would be built around that capability?
Yeah.
It's definitely something to mull over.
A great question to end on. We'll catch you on the next deep dive.